So in solving this first equation, this first system of equations, we know that the second equation, we know what y equals. We know that y equals this 3x minus 2. So what I'm going to do is I'm going to take what y equals, and I'm going to replace the y in the other equation with that. And so I'm just literally rewriting that first equation exactly as it was before, 4x minus, except instead of writing y, I'm writing what y equals, the 3x minus 2. Now, a little bit of a caution, because some of you will have written this, but there's going to be a problem if we just write it like this. Because you'll notice that I am subtracting y. That means I'm subtracting all of y. Right now, this shows that I'm subtracting the 3x, but the minus 2 just stayed a minus 2. If I subtract a negative 2, that should become a plus, right? So when you write this out, put the parentheses around that. That way you're going to remember that this negative is actually going to go into both of those terms. And if you remember that, then solving it out from there, not going to be too bad. This is what the rest of the work would have looked like as you went through. And so you can see we end up with a final answer here of negative 1, negative 5. All right, we're now going to be taking a look at how to solve this system of equations. So what I'd like you to please do, write down the system, of course, and then go ahead and start solving it out. Now, I know you're probably not done with it yet, but I want to go ahead and start taking a look at how you're approaching this, because the very first thing that you're probably going to have to do here is give us a variable that we can substitute, right? We're going to need to know either what y equals or x equals in one of these equations. Well, if I'm looking at these two, that to me means I'm going to want to make this second equation be x equals, because that's the only one that looks like it's really going to be particularly easy to solve for. And if I do that, this is what I would get from my work. I'd solve that second one to be x equals, then I could plug that in and solve it through using what we've always done. And this works, and it's valid. But of course, in this case, it was made a little bit easier by the fact that this was just an x. Imagine if that was like a 9x or something. This all could get really messy really fast, right? And so we do have another method. And that's what we're going to be focusing on today. Today we're going to be looking at another method that can be used to solve this sort of a system of equations. Now, when I say this sort, what makes this method that we're taking a look at today particularly useful is that you'll notice that it starts off with the x's lined up above each other. The y's are lined up above each other. The numbers are lined up above each other, and even the equal signs are lined up above each other. Everything here is lined up vertically. What we're going to be using here is called the elimination method. And so yesterday was all about the substitution method. Today is all about the elimination method. And so the whole idea behind this method, and partly why we have to have everything lined up vertically, is because we actually are allowed to add equations together to get new equations. And it turns out that when you add two equations together, the resulting equation will have the same solution as the original equations. And so, if I take my two equations here and I add them together, notice I'm just adding straight down. So I'm adding the x's, so 2x plus x is 3x. Then I'm adding my y's. Now this is the critical piece right here, and why this method is going to work. Because negative 3y plus 3y is 0. The y is eliminated when I add them down, hence elimination method. That's why it gets its name there. And then, of course, the equal sign, it just carries down to where it was. And then the numbers, I just go ahead and I add those. Now you notice what that accomplished for me. After I added them, I ended up with one equation with one variable. That's what we are wanting. We're wanting just one equation with one unknown. Because if I can do that, then I can solve it. And so you notice, I'm getting the x equals 4. All right, but just like before, once I know what x is, I still am going to have to figure out what y is. Well, the same way that we did with substitution method, once I know one value, I can take that one value and I can plug it back in to either of the original equations. In this case, I'm choosing to plug it into the first equation. So I plug the 4 in for x in the first equation, and then it's a matter of solving it from there. You'll notice that with the elimination method, this second step tends to be slightly longer than it was with substitution. Because with substitution, we had an equation that said like y equals this. So all you had to do is plug it in and figure out what y equaled. In this case, you actually have to do a little bit of algebra, moving stuff side to side. But you will still get the same answer. Between the two methods, they both tend, when you look at the whole big scheme, they both tend to be about the same amount of work by the time you're done with it all, as long as you choose the right method for the problem. You technically could use either method with any given set of equations, but some of them are going to get real ugly if you try to do it. So try to look out for which ones to use when. I use elimination method when everything's lined up. Basically, it's going to be typically standard form for both equations. I'll use substitution method, the one we were focusing on yesterday, anytime I have one of the equations at least that's either x equals or y equals. And that's for substitution. Write down this equation. We're going to see what happens when it's not set up quite as perfectly as that last one was. All right, now if we take a look at this one, you notice it's set up nicely for using elimination method. Because again, both equations are in standard form. My x's are lined up above each other, the y's are lined up, the equal signs are lined up, and the numbers are all lined up. Which tells me that if I'm going to use elimination method, then I would start adding them straight down. Don't write this yet. Because if I add these straight down, I end up with 3x plus 5y equals 35. And while that is technically correct, and while this will still have the same solution as our original system of equations, this did not help us because we now have one equation with two unknowns. I can't solve that. I can't make that useful to me. So we have to do something else before we add or subtract them. And in order to do that, what we're going to do is we're going to make it so that one of the variables will add to 0. Now you technically could choose either one, but just for this first one, I'm going to make a choice right now and say we're going to make it so that the x's are going to add up to 0. Now in order to do that, I'm going to have to multiply either one of them, or you can even multiply both of the equations by different things, and that's going to be okay. But in this case, we only got to multiply one of them. Notice I already have a 2x here. What would I have to make this x so that that plus 2x equals 0? Yep, it'd have to be a negative 2x. So what then would I multiply it by to make it into a negative 2x? Negative 2, yeah. And so I'm going to be multiplying that equation by negative 2. Now notice I said that equation. That means everything in that equation on both sides is getting multiplied by negative 2. Now when we do that then, we need to rewrite now what is our new system of equations. What's our system now going to look like? So for the first one, I'm just going to multiply everything through by negative 2. And so my first equation, you'll see the results there. The second equation, I did not multiply it by anything. Now, it can be very tempting to say, I didn't change the second one, so I'm just going to leave it there. I don't even need to rewrite it because I didn't change it. But the problem is that if you start doing that, you're going to go and you're going to like add the 2x and the 2x, then you'll add the y and the y, and then you'll add the 58 and the 29. Or something like that will happen, where because you're having to look up at previous work to find it, you're eventually going to grab the wrong number or something like that. And so what I'll always tell you to do is rewrite both equations. Even if you didn't change one of them, rewrite both of them. Now this is still a system of equations at this point, so we still include that curly bracket next to it. Now if your curly brackets look really weird, the good news is they will improve over time. Mine looked hideous for years and years, but give me a few years and eventually I'll get them looking halfway decent. Keep at it. And then from here, notice you can go ahead and use our elimination method just like we talked about in that first problem. It's going to work the same way it did before because now you can go ahead and add those equations, so please do so. Go ahead and finish solving this problem out now using elimination method. So here you can see how that ends up working out, how we find our solutions. Now, you may recall that at the start, I made an arbitrary decision. I decided that we were going to start this problem by making the x's eliminate. It really was an arbitrary choice, though. There was nothing magical about this that said I had to make it so that x's would add to 0. I could have also done it so that the y's would add to 0. So let's just take a moment and think about how would I have done that. So I'm looking at my y's, and I have a 6y, and I have a negative y. Be thinking about what would I make them both into so they would add to 0. And then you would think about, okay, now which one do I multiply by what in order to get that? Well, notice the first one's a 6. That means that second one I can turn into a negative 6. What would I have to multiply it by in order to do that?
I know.
6. And so you also could have done it this way. You could have multiplied the second equation by 6 instead. And if you'd done that, you can see the work and how that works out, and you still end up with the same solutions, which is good. It works either way. Now, some of them might not even be set up this nice. You'll even see some where you're going to have to maybe multiply both equations. And if that's the case, you would multiply them both by different numbers. And we're going to see one of those coming up next. But just realize that it is your choice. And usually you're just looking to see which one is going to be more intuitive for you to make cancel out, to make eliminate. But it is your choice about which one you choose to go with. This is the last problem we're doing together. Go ahead and write down the original system and then pick a variable that you want to have eliminate and then do the multiplication to make that happen. Now, when you are looking at this and trying to make that decision about which one you want to eliminate, it really is a personal choice. And in this case, there's really a number of different options. For instance, let's say I wanted to make the x's eliminate. I see a 5 and a 3. Well, what do both 5 and 3 go into? 15. So I might be thinking, okay, I want to make them both into 15 x's here. But of course, if they're both 15, that would add to 30, not 0. And I would need it to be 0. And so I need to make one of them negative. Does it matter which one I make negative? Not strictly speaking, no. Again, it's a personal preference. You can make the first one a negative 15, or you can make the second one a negative 15. Either one of those would work as an option. Or, let's say you're looking at the y's and wanting the y's to eliminate. So, looking at the y's, you might have said, okay, well, what do both 6 and 4 go into? Yeah, I think 12 would be a great number. And so I might say, okay, well, I want to make it into a 12y and a 12y. But notice that bottom one, it's already negative 4. So it makes sense to make that bottom one the negative. Now, did you have to use 12? What if we used 24 instead? Could you have done that? Would it work if you turned them both into 24 and we're just multiplying the top one by 4, the bottom one by 6? Yes. All of those would work. In fact, that 24 is so common that I used it in my example up here. This is what your first step would look like depending on which one of those you used. Now, if you didn't quite get that first step and know how that would look, well, here it is shown for you. And then once you get to that point, finish solving it out from there.